Now this is unit 4, first topic, stacks and subroutines. Now what is stack? Stack is a LIFO data structure which is employed in a RAM memory that is used to store the temporary data. So now in 8085, stack is defined by setting the SP register. Now if this is the huge memory in the um, processor in the system, then part of the memory is used for the storing the data temporarily. You know, this few locations, a set of locations are called as stack. And always the top of the stack is held by the SP, stack pointer. It is a 16-bit register. In 8085 address, we are indicating by using the 16 bits. So SP is also 16-bit register. Now how to save the data onto the stack? By using the push and pop instruction. Now, if you see push RP means what? Push register pair and pop register pair. Now, here the register pairs are B, C, D, E, H, L. Three register pairs are there. Now, if you specify push B means BC register, push D means DE register pair, and push H. Now, here in this, whenever we are using the register pair, that time we don't use two register. Only the first register we indicate. The meaning of that is what? Both the registers. Now if I take push B means what? BC register, whatever the data is there, that data is moved onto the stack. Now coming to the pop, if I say pop D means what? From the stack, we are loading the content onto the DE register pair. Then how this data is moved, that we will see in detail in push RP. Now push register pair means what? Now here if this is a stack and SP is holding the top of the stack. Now if you consider this is the top of the stack, when we give the push RP means first SP is decremented by 1 and it is pointing to the this location. It is -1 location. Now, for example, if I take this location is the 4009 location, then it will be decremented by 1 and it is pointing to the 4008 location. Now, in this location, higher register value. Now, if you take BC, DE, HL, these are the register pairs. In this is called the higher register. And this is called these three are called the lower register. Now, if I use push B means what? In this B is the higher register and C is the lower register. Now B value is moved on to the 4008 first, and again one more time it will be decremented and it is pointing to the 4007. Now in this memory location C value is moved. So this is about the push operation. Now coming to the pop operation, similarly now if I take pop D means what? So DE, we are moving the content from the memory location. Now, if wherever the stock pointer is there, now for example, stock pointer is in the 4007 location, now 4008 and 4009. If stock pointer is pointing to 4007, now whatever the data is there, that data is moved into the lower register first, and it will be incremented by 1, and the next value memory location value is moved on to the next register, higher register, and again it will be incremented by one more time and it points the next location. Now this is about the pop instruction. Now here also 2-time increment is taking place, but wherever the stack pointer is there, that location value is moved on to the lower register, incremented by 1, and in that location whatever the value is there, that is moved on to the higher register and again incremented by one more time. Now the stack pointer is pointing to 4009. Now this is the operation for the pop. Now we will see one example how to write the program and how the content is moved. Now here SP 2099 means what? Stack pointer is initialized by using this 2099 means what? Stack pointer is pointing to the 2099 in the memory location. Now after that LXI H comma some data is given means what? Whatever the data is there, this data is moved on to the HL register. Now it is HL is pointing to this location is nothing but what? In the H, now if you see here, HL register, in the H, in this data, this is called the lower byte, this is called the higher byte. Lower byte is moved to the lower register, nothing but L register. F2 is moved on to the L register, and 42 is moved on to the H register. This is a higher byte moved to the higher register. Now this is the data. Now after giving the push H, what happens? We will see. Now push H means what? If the stack pointer is pointing to 2099 means it is supposed to decrement by 1, and in this location 40 to higher register value should move, and again decremented by 1 and lower register value is moved. Now this is about the pop operation, push operation. Now after the some delay, if the pop operation is given, now pop H means what? Whatever the data is there in the memory is moved into the HL register pair. Now in this case, pointer is pointing to 2097. So now after giving the pop H means the whatever wherever the stack pointer is there, that memory location content is moved onto the L register, incremented by 1, and the location value is moved onto the H higher register H, and again incremented by 1, and now it is pointing to 2099. Now this is the pop operation. Now next, coming to the subroutine. Subroutine is nothing but a set of instructions which are written separately from the main program, and repeatedly called into the main program wherever those set of instructions are required. Now for example, this is the main program. Now here you can see this is the main program. Now in this, these are the few instructions are written separately. Now in this main program, these instructions are repeatedly used. So instead of writing these instructions within the program, written separately, and this set of instructions together is called as a subroutine, and the last instruction is the written instruction. Now whenever this program is needed, there they use the call instruction. So now call address location. Now if this program is written in the 2103 means what? Call this address location after giving that. So whenever this instruction is executed, it will jump to that location, and whatever the instructions are there, it will be executed. And after executing the written instruction, again it will come back to the main program, and the main program remaining instructions are executed. Now this is about the call instruction. The instructions which are written separately, those are called the subroutine. That program is called the subroutine. Now here, how again the processor will come back to the main program means what? Whenever the call instruction is executed, it will say now it is holding the next executable instruction. PC always holds the next executable instruction. Now this PC value is moved onto the stack, and it will jump to the 2130, and it will execute. When the written instruction is executed, again it will go back to the stack, and whatever the address is stored, that address is again stored onto the PC. So this inside, if call instruction is executed, automatically to save the PC value, again processor is using the push and pop instructions internally. Now I will write one program for the subroutine. By using subroutine, how to write the program, we will see. Now if I wanted to add three numbers, 1, 2, 3, if I added three numbers, then how to write the program? First we will see. Now here I am initializing the move immediate a comma 0 0. I initialize the accumulator with 0 0, and I initialize the b with 0 1. Why? Because I wanted to add these three values. I can initiate to the registers directly, or if you wanted to load in the memory location, that also we can do. Now move immediate b comma 03. So three values for three values I loaded into three registers. Now I have to do the addition. That addition I will write separately. Now here initialization is over. Now here I'll use the call instruction. Now where to jump? Now if I take this, if I'm writing the program at 6000, this is the 2-byte instruction, 2-byte instruction, 2-byte and 2-byte. So every instruction occupies two locations. So now 6000, next 6002, next 6004, 6006, now 6008. But call, and I'm giving the address here. It is a 3-byte address, 3-byte instruction. Call, after that I'm giving the 16-bit address means what? It is a 3-byte instruction. So 9 and A, it occupies the three locations. And after that, what I am loading the data into some location, or directly I can use the address is in the accumulator. So STA and what wherever I wanted to store. Now, if I wanted to store the result in 6050, now after getting the result, I wanted to store this result into this location. So I'm using the STA and after that what? Halt. So now now I'm using the 600B and here it is occupying the three locations. So B, C, D it is STA is taking. Now halt I am writing at 600E. E. Now here I have to write, now where I'm jumping to F, 600 F if I'm jumping. Then here in this, I have to write it is not mandatory that after that immediately you have to take, which location you want, you can write. Now in the F, I am writing the subroutine. What is the subroutine? Subroutine is nothing but what? Adding these three values. So first I have to add with the accumulator. Now I'm adding B value first. Now after the result is again in the accumulator only, I'm adding the C value. So these are the single byte instructions. After F, I'll get 0. And next after that adding the D. So this is what 0, 1, 1. All these three are single byte instructions. Now after that what? Return. So this is nothing but what? 2. Immediately it will go back after executing the written instruction. It will go back to the next again to this location. How it is going? So whenever the call instruction is executed, this PC is pointing. PC is nothing but a program counter is pointing to the next executable instruction, means what? This location. Now this will be stored onto the stack and it is jumping to this location and it will execute these instruction, and after the written instruction again it will go back to the stack, and whatever the data on the stack again that is moved onto the popped onto the PC, and next instructions are executed in the main program. Now this is the program how to write by using the call instruction or using subroutine. Now with this, now here the same program I have written in some other pattern. Now here SP value I have initiated to the 5000. Or if you are not initiating, means what? Wherever the pointer is there, it will load the data onto that location.